In this video, I'm going to talk about a little bit what's going on in Conceptual Example 2. This is on page 267 of your book. And this is all about the idea that shorter springs should be stiffer springs, all else being equal. And they actually go to great lengths to convince you of that, but add in some details that I don't think really make it any clearer. And what I'm going to focus on is the equivalent of what's in this picture in figure 10.3, minus all the Newton's third law stuff, because I think I have an easier way for you to get a handle on exactly what's going on there. But their method is completely valid. So I'm going to have a spring here, and I'm going to call this, it has a spring constant K, and we have some certain displacement and a force there associated with it. And then we're going to chop it in half. Okay, so we're going to apply some force here. Sorry. We're going to apply some force here, and then we're going to chop this in half. Well, if I'm pulling down on this with some force at this location, that will be the same force the spring experiences here, 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 all along the way down. So if I cut it in half in this like little thought experiment here, we just do that, my force on this half at this location will be the same as what it was here. It'll just distribute up through the spring. So let's chop that in half, okay, and keep the force the same. So when I chop that in half, whatever displacement I had here, now of course will get cut in half. So we'll have 1/2 x here, 1/2 x here, okay, if we're applying that. And now let's take a look at F equals kx. Well, I know this is going to be the same based on the idea that throughout here the force is the same, and I'm going to lop off the bottom half. So I have the same force, but I know I get half the displacement. Well, if I have the same force acting on it down but get half the displacement, I cut this in half, I'm going to have to double my k. So the new k for this shortened version right here, okay, is twice the original. So the new k is 2 times the original. In other words, the spring got a lot stronger or a lot stiffer. This, I think, agrees with most people's understanding of springs. Another way to think about it would be if you have the same kind of build for a spring and it's a very short spring and try to pull it, you have to pull a lot harder to get the same displacement. That's the other way to attack this from just a very conceptual standpoint. If you don't like this whole the force is the same throughout here, that's where you can go to the book and start to apply Newton's third law. That's similar to like when we've done stuff with tension in ropes. If you have a tension in one spot, it's the same throughout the rope. That should work okay here for your spring stuff as well. That's it.